So far in this course, we've been working with right triangles. So what happens when we don't have a right triangle? We can't use the trigonometric functions and the ratio of sides like we've been doing before. We can't use the Pythagorean theorem. So there's some other formulas that we can use when we don't have a right triangle. Today, we're going to look at the law of sines. And first, we're going to derive how we get the law of sines. So in front of us is a triangle. Let's label the angles and the sides. So recall angles we denoted sometimes by capital letters, and the side opposite of that capital letter was lowercase. So the lower left-hand corner is angle A. Across from that would be side A. Let's say the upper angle of this triangle is B. So the side opposite this would be side B. And the lower right-hand corner is angle C. So the side opposite is side C. So we don't have a right triangle, but let's create this as a right triangle. Then we can use what we know. So let's divide this into two separate triangles. And so we have a right triangle on the left, and we have that triangle on the right is also a right triangle. Let's denote that height as h of 1. We're going to have two different heights later, so we want to distinguish between the heights. So I'm calling that's why I'm calling it h of 1. Now I have this right triangle. So let's look at this. If I use my opposite side, which is the height of angle A, and then my angle C is going to, not my angle C, my side C is going to be my hypotenuse. So opposite and hypotenuse tells me I'm going to use sine. So we have sine of angle A. This is equal to the opposite, which is side h of 1, all over the hypotenuse, which is C. So let's do the same thing with our angle C. So for angle C, the opposite is our h of 1, and our hypotenuse in that case for that triangle would be A. So rewriting that, we have sine of angle C. This is h of 1, opposite of that, all over the hypotenuse, and that would be side A. So notice both of these have h of 1 in common. So let's solve for h of 1 in each case. So all we're doing is getting rid of the denominator. So for the first equation, sine A equals h of 1 over C, we're just multiplying both sides by C. So doing that, we get side C sine of A is equal to h of 1. Doing the same sort of idea for the second equation. We're going to solve for h of 1. We can multiply both sides by A. So here we would get A times sine of C is equal to h of 1. So now we can just set these equations equal to each other. H of 1 equals C sine of A, and h of 1 is equal to A sine of C. So we have here C sine of A is equal to A sine of C. So if I divided both sides by those coefficients in front of my sines, so if I divided both sides by AC, for that expression on the left-hand side of my equation, my C's are going to cancel. And on the right-hand side of my equation, the A's would cancel. And so here we're getting part of our formula, which says that sine of A all over side A is equal to sine of angle C all over side C. So angle B, side B is a little jealous. They've been left out here. So let's redo this. But now let's rewrite another triangle. So, or break this main triangle up into two triangles. So I'm going to get rid of my H of 1 for right now. And instead, let's say that we had chosen the base to be that left-hand side of my equation. Or let's break it down. How about like this? So here, and we're creating right triangles in here. And so we can do the same thing that we were just doing. So from angle A, and let's call this height H of 2. Excuse me. Okay, so from angle B, opposite would be H of 2, and the hypotenuse is going to be side A. So let's look at sine of angle B is equal to the opposite, which in this case is H of 2, all over the hypotenuse, which is A. So looking at the other angle we know, sine of A, we can do the same thing. So we know that sine of A in this case is equal to the opposite, which is H of 2, all over the hypotenuse, and the hypotenuse in this case is side B. So again, let's solve for H of 2. And so if we solve for H of 2 in each case, we get H of 2 is equal to multiplying both sides by side A times sine of B. The other one, multiplying both sides by B, we get B is equal to, sorry, not B, B times sine of A is equal to H of 2. So now we can set these equations equal to each other. And so we know that A sine of B is equal to B sine of A. Again, if we divide both sides here by the coefficients in front of our signs, so A, B in this case. For the first side, left-hand side of our equation, our A's would cancel, and we would be left with sine B all over side B is equal to sine A all over side A. But up here, we had just solved that sine A over A. We have sine A over A here. So we can say, well, then sine A over A, we also know is equal to sine B over B. So we could just add this into our equation up here. So here is the law of our sines. I like to leave it in this form. If we're given a triangle, we're trying to find our angle. But if we're given a triangle and we're trying to find our sides, and these are non-right triangles, if we had right triangles, we wouldn't use the law of sines. But if I was trying to find my sides, we could cross multiply and you would get that, well, A over sine of A is the same thing as C over sine of C. Doing some manipulation, we would get this, which is equal to B all over sine of B. It just makes it easier when we're solving because the unknown is in the numerator versus the denominator if we use it that way. So that is the law of sines. So now let's look at a couple of examples. actually, before we look at a couple of examples, let me also tell you when we would use this. So notice that in this case, we have an angle and a side opposite of the angle. So you're going to use law of sines when you know an angle and the side opposite of the known angle. If we're given two angles and a side, we can use law of sines. It will come out that we have one triangle. We'll see a little bit later that if we're just given an angle and multiple sides, then it's possible that no triangle exists, one triangle exists, or two triangle exists. I always assume that there's two triangles, and if there's not, then I get a contradiction and it starts to fall down that, okay, well, there's one triangle, there's no triangle. But let's look at a case where we're given two angles and a side across from an angle known. So the example in front of us is angle B is equal to 10 degrees, angle C is equal to 100 degrees, and side B is equal to 2. So notice I have an angle B and I have a side B. So I'm going to use the law of sines. I also notice that I have angle B and angle C. So recall that the sum of all angles of a triangle has to sum to 180 degrees. So we can easily get the angle A by looking at 180 degrees minus the sum of the two angles we know, which was 10 degrees plus 100 degrees. So angle A here, this is equal to 180 degrees. Order of operations, do what's inside the parentheses first. 10 plus 110, 10 plus 100 is 110. 180 minus 110, this gives us 70 degrees. Okay, so now we just need to figure out what side C is and what side A is. And then we have our triangle completed. And so let's use what we're given. And I'm trying to find a side, so I'm going to put the sides in the numerator. So we're given that side B, 2, all over sine of angle B, which was 10 degrees, is equal to side C, all over sine of angle C, which is 100 degrees. Let's isolate side C by itself. We can do that by multiplying both sides of our equation by sine of 100 degrees. On the one side, the sine of 100 degrees is going to cancel, leaving us with just C. So C is equal to 2 times sine of 100 degrees, all divided by sine of 10 degrees. So we want to plug this into our calculator. We want to make sure that our calculator is in degree mode and not radian mode. Also be careful when you're plugging this into the calculator. Make sure that you're closing off the parentheses of your angle if it starts there for you before you divide by that sine of 10 degrees. If not, your calculator is going to read that wrong order of operations. So let's plug that into the calculator and see what we get. So plugging it into my calculator, I get that C is approximately 11.3. So I'm just going to round to the whole number in this case. So C is equal to 11. But on your homework exercise or on your exam, see if it tells you what they want you to round to. So we get side C is 11. So now we want to find not angle A. We already found that. We want to find side A. When I do this, I'm going to use what I'm given just because I did some rounding for that C value. And so to get a more accurate result, I'm going to use what I didn't round, which was given to me. So I have side B, which is 2, all over sine of angle B, which is 10 degrees. This is equal to side A, which we're trying to find, all over sine of angle A, which we found to be 70 degrees. Multiply both sides of our equation by sine of 70 degrees, we would get that A is equal to 2 times sine of 70 degrees, all over sine of 10 degrees. So plugging that into the calculator, 2 times sine of 70 degrees divided by sine of 10 degrees, we get that this is approximately 10.8. So I'm going to just round it, and I get that side A is approximately 11. So given two angles, a side opposite of an angle we know, we could use that law of sines to figure out all of our sides and angles that weren't given. So that's not too bad. Now let's look at a case where we're just given one angle and we're given two sides. So I had just mentioned that it's possible that no triangle exists, one triangle exists, or two triangles exist. Again, I just assume there's two triangles and then start solving. If there's not two triangles, I'm going to get a contradiction. If there's not one triangle, I'm going to get a contradiction. And then I know that there's no triangle. So let's look at an example here. So let's say you're given that side B is 2. We're given that side C is 3. And we're given that angle B is 40 degrees. And we want to find the remaining side and angle A and angle C. So with what I'm given, I have angle B and the side B. So I have the side opposite of that. And I have side C. So I want to find angle C first. So I want to find an angle. I'm going to use the formula where the sign of the angle is in the numerator. So I have sine of angle B, which is 40 degrees, all over side B, which is 2, equals sine of angle C, which we don't know, I'm trying to solve, all over side C, which is 3. So we want to get angle C by itself. We can do that first by multiplying both sides by 3. So we get sine of C is equal to 3 times sine 40 degrees, all over 2. I don't want sine C, I just want angle C. So I know that I can take the inverse sine of both sides of my equation. And so doing that, I get sine inverse of sine of C. This is equal to sine inverse of 3 sine of 40 degrees, all over 2. So angle C is equal to the sine inverse of 3 sine of 40 degrees over 2. So let's plug this into our calculator. The thing is, recall that sine is positive in multiple quadrants. Sine is positive in quadrant 1 and quadrant 2. So the result that we get from our calculator, that is going to be the angle that's in quadrant 1. And so we also have to treat that as our reference angle in quadrant 2. And that's going to give us the angle C for our second triangle if it exists. So let's first plug in here 3 sine of 40. Close my parentheses, then divide that by 2. Oops. I get 0.964. So it's really C is equal to approximately sine inverse of this 0.964. So I'm going to not round this in my calculator. Now I'm going to just take the sine inverse of my answer. And so doing that, I get approximately 74.6. I'm going to round to the nearest degree. So rounding that to the nearest degree, I get that my angle C is approximately 75 degrees. Okay, so triangle 1. We just found that angle C is 75 degrees. Triangle 2. We're going to assume that this 75 degrees is the reference angle in quadrant 2. So 180 degrees minus 75 degrees is 105 degrees. And so in triangle 2, angle C is 105 degrees. So now we have angle B and we have angle C. We can find angle A in both cases, triangle 1 and triangle 2, by looking at 180 degrees minus the sum of the angles we know. So 75 degrees plus 40 degrees. So I have 180 degrees minus 125 degrees. Let me just check that. It's really early in the morning, and so it's possible. It's 115 degrees. So 40 plus 75 is 115. 180 minus 115, that is going to get me 65 degrees. Again, it's really early in the morning, so it's more apt for me to have errors. So I'm just going to check it in my calculator. Yep. So A is 65 degrees. That's for triangle 1. Triangle 2, our C is different. So our angle A in this case is 180 degrees minus the sum of the angles we know, which is the 40 degrees plus the 105 degrees. So A here is equal to 180 degrees minus 145 degrees, which is equal to 35 degrees. So if a second triangle didn't exist, what would have happened? We would have solved for side or angle A for that second triangle, and the sum of the two angles we knew is going to be over 180 degrees, which would give me a negative angle, which doesn't make sense for a triangle. And so that would be a contradiction, and we would say the second triangle doesn't exist, and we would continue with the first triangle. We'll see that if no triangle exists, when we were trying to find that first angle, And we looked at, getting that angle by itself like we did over here, C. And we plugged in this information before we plugged in the inverse, took the inverse sign of it. We would have found that this value in here was greater than 1 or less than -1. And we would get then an error in our calculator because we know our sine function's range is between -1 including and 1 including. And that would be falling out of the range, which is our domain of our inverse function. And so we would get an error there and no triangle would exist. So that's just kind of talking through what would happen if you had one triangle or no triangle, but we now saw that we have 2 triangles. We're almost there. We just are missing our side A. So side A we can find again by law of sines. And so we have side A all over sine of angle A. For the first triangle, we said that was 65 degrees, is equal to, again, I'm going to use what I know, side B, which is 2, or was given, all over sine of angle B, which is 40 degrees. Multiply both sides by sine of 65 degrees, we get A equals 2 sine of 65 degrees, all over sine of 40 degrees. And then I'm going to plug that in the calculator, but let's first go and figure out what side A for triangle 2 is. And so we can just do that at once. So we have side A, which we're trying to find, all over sine. In our second triangle, our angle A is 35 degrees, is equal to 2 over sine of 40 degrees. Solving for A, we get 2 times sine of 35 degrees, all over sine of 40 degrees. So plugging that in, I have 2 sine 65 all divided by sine of 40, which gives us approximately A in our first triangle is approximately 2.8 or 3, rounding to the whole. A in our second triangle, 2 sine of 35 divided by sine of 40, which gives us approximately 1.78, which rounds to 2. So 2 triangles exist, and we found the rest of the angles and sides of the unknown. Okay, so we have the next example in front of us. We had side B is 5, side C is 3, and angle B is 100 degrees. I just want to read the directions because I think sometimes students, they get a problem and they're not familiar with the directions, and getting familiar with the directions and the wording is going to help you when you get to an exam or trying to solve a problem. So the problem says 2 sides of an angle are given. Determine whether the given results determine whether the given information results in 1 triangle, 2 triangle, or no triangle at all. Solve any triangles that results. Sorry, the lighting is not that great in here and my eyesight's going. So, but anyways, so looking at this, I see I have side B and angle B, and I have side C. So that tells me that I need to look for angle C first. And so we're going to look at sine of angle, or sine of angle C, all over side C, which is 3, is equal to sine of 100 degrees all over side B, which is 5. Let's multiply both sides by 3. So we have sine of C is equal to 3 sine of 100 degrees all over 5. We want angle C, so we could take the sine inverse of both sides of our equation. And so we get angle C is sine inverse of 3 sine of 100 degrees. And that piece, that argument is divided by 5. So looking at this in our triangle, 3 sine of 100, I'm just going to go inside the argument first. Close my parentheses, divide that by 5. I get my output is 0.59. So that is falling within the range of sine between -1 and 1. And so when I take the inverse of this, I'm not going to get a problem. So taking the sine inverse of my result, I get back approximately 36 degrees. So this is again triangle 1. I have angle C is 36 degrees. It's possible though that we were in the second quadrant instead of the first quadrant, because sine is also positive in that second quadrant. And so C would be, that's my reference angle. C would be 180 degrees minus this 36 degrees. So C would equal 144 degrees. So now let's find the missing angle, angle A, and we can do that because we know that the sum of our triangles, angles of our triangles, 180 degrees. And so A is equal to 180 degrees minus the sum, 100 degrees plus 36 degrees. So it's 180 degrees minus 136 degrees. So that would get me 44 degrees. So let's go to triangle 2. A would equal 180 degrees minus the 100 degrees plus the 144 degrees. So right here, I can see that there's an error. I'm going to get a negative answer for my angle. Excuse me. It's that time of year, allergy season, man. So 180 degrees minus 244 degrees. That is a negative angle. So this is not possible. Which means that our second triangle does not exist. So we just need to continue working on that first triangle. And we know one triangle exists, or we would have already had that error coming through. So now we just need to figure out what side A is. So side A all over sine of angle A, which is 44 degrees, equals side B, which is 5, all over sine of angle B, which was 100 degrees. So multiplying both sides by sine of 44 degrees, we get A is 5 times sine of 44 degrees all over sine of 100 degrees. So plugging that into our calculator, we get 5 sine of 44 in parentheses divide by sine of 100. You could end your parentheses there too, And we get that that's approximately 3.52. Or if we rounded, it would be approximately 4. Or if we rounded to the nearest tenths, it would be approximately 3.5. Okay, so we figured out there was one triangle exist, and we found the remaining angles and side. So let's look at one more case scenario, and then we'll get to the fun part where we're using this law of sines to help us solve application problems. So let me pull up another example for us. Okay, so in front of us, we have side A is equal to 2, side C is equal to 1, and angle C is equal to 100 degrees. So the first thing that we would look for is our angle A. And since I'm looking for an angle, I'm going to put the sign of angle A in my numerator. All over side A, which is 2, equals sine of angle C, which is 100 degrees, over side C, which is 1. So let's multiply both sides by 2. We get sine of A is equal to 2 times sine of 100 degrees. We want angle A, so we could take the sine inverse of both sides. And so we get angle A is sine inverse of 2 times sine of 100 degrees. Plugging that in. So I'm first going to plug in 2 sine of 100 degrees. And I find that that is about 1.97. I know that that is bigger than 1. And so I know that when I look at sine inverse of that value, 1.97, there's going to be an error. It's going to say error domain or something in your calculator when you plug that in. So this is not possible. And this was trying to find my first triangle. If the first triangle doesn't exist, that means my second triangle is not going to exist either. And so no triangle exists with the information that we're given. Okay, so let's look at some applications and apply this law of sines to some applications. Our next problem in front of us is about bridge design, and it says a bridge is to be built across a small lake from a gazebo to a dock, and there's a figure below. The bearing from the gazebo to the dock is south 41 degrees west. From a tree 100 meters from the gazebo, the bearing to the gazebo and the dock are south 74 degrees east and south 28 degrees east, respectively. Find the distance from the gazebo to the dock. Okay, so we need to do some math in here. And we're going to be using our law of sines. So sometimes we're going to be not given the picture, and we're going to have to draw our picture itself. But we're given this picture, and let's look at what we have. So in here, we have, okay, we know one side. We are going to need to know what the angle of the side across from the one side known is. So we know this side, and we want to figure out what this angle theta is. We know that this angle over here, this is 74 degrees total, and this is 68 degrees. And so 74 degrees minus that 28 degrees is going to give us that angle inside of the triangle in the upper left-hand side. So that gives us that this angle inside, right here, this angle is 46 degrees. Okay, so let's see, what else do we know? Thinking about parallel lines. Okay. Okay, so we have two parallel lines in here. Let me just draw them. Right here and right in here. And so there's a rule about parallel lines being cut by another line. So let's think of that 100 degrees as cutting it. I'm going to do it so that it's like this. And so I know that this, or it's given that this is 41 degrees. And so to be congruent, I know that this angle in here which was 74 degrees. Opposite, so this would also be 41 degrees. And so I know that to get up to from 41, which is not, this would come down. Let me think about this for a second. Okay, so it took me a minute to figure this out. It's been a little while since I've had geometry. I normally don't teach geometry. I've never taught geometry actually. But anyways, in front of us, I pulled up some congruent angles and corresponding angles that are congruent to one another. And so we're going to use this fact to help us figure out the angles that we know. I put down those two vertical lines that we had. I put down the transversal line that cut those two parallel lines. And then I just extended this line from the dock to the gazebo up a little more. And so we know that this angle in here is 41 degrees. So we know the angle over here is also 41 degrees. This whole angle in here between that vertical line and the transversal line, we were given with 74 degrees. So this is 74 degrees. And so I know that the angle up in here is also 74 degrees. So if that's 74 degrees, looking at the alternate, then this here is also 74 degrees. We know that line, the angle from one side of the line right here to here, it has to be 180 degrees. So if we sum 74 plus 41, that would give me this angle in here. So 74 plus 41 is 115 degrees. So if I subtracted off 115 from 180 degrees, this is going to give me 65 degrees, which tells me that this angle inside here, I'm going to use a different color, is 65 degrees. So this angle in here is 65 degrees. So knowing that this is 46 degrees, this is 65 degrees, I could figure out what theta is. So theta is equal to, you know, the sum of a triangle is 180 degrees. So 180 degrees minus 46 plus 65. So 46 plus 65 is 111 degrees. So I have 180 minus 111, which is 69 degrees. So now we're given, or now we know, an angle and a side across from that angle. This right here, we've been doing orange side. So this right here is 69 degrees. So now we can use that law of sines to help us solve. We are trying to find this length in here, our bridge. Let's call it X. So we have angle 69 degrees is across from side of 100 meters. So I have 100 meters all over sine of the angle across, which is 69 degrees, is equal to the angle across from the side that we want, which is X, all over sine of the 46 degrees. So X, if we multiply both sides by sine of 46 degrees, is 100 sine of 46 degrees, all over sine of 46 degrees, 69 degrees. So 100 times sine 46 divided by sine of 69. So that gives me approximately 77 meters. So that's the length of our bridge. Okay, so I thought that one wasn't going to be too bad because we were given the picture, but we had to really kind of think about the angles and being congruent. So what I had posted right here about the corresponding angles, alternate angles, and alternate exterior and alternate interior angles of parallel lines intersected by a transversal line could be helpful when you're doing these problems. So let's pull up another problem. Problem in front of us says, John needs to determine the height of a tree before cutting it down to be sure it does not fall on a nearby fence. The angle of elevation of the tree from one position on a flat path to the top of the tree is 30 degrees. And from a second position, 40 feet further along, this path is 20 degrees. What is the height of the tree? Okay, so we have some path. And from the path at one spot, an angle of elevation. So from the horizontal, we're going up 30 degrees. We get the top of a tree. Okay, let me make my tree. Oh, let's do that later. So 30 degrees. If he goes 20 feet further along the path away from the tree, that angle of elevation to the top of the tree is now 20 degrees. "40 feet further along." And we want to know what's the top, how high is this tree? Okay. And maybe just make sure that I've copied everything down. Okay, so we do have all the information. So let's look at this one triangle right in here. Let me just draw it really quickly. So we have 40 feet in here. And with that 40 feet, I'm just going to magnify it a little bit. We know that this right in here is 30 degrees. So I could figure out what this angle is right in here. So I know that that sum with the 30 degrees and the angle I'm trying to find has to be 180 degrees. So this angle in here would have to be 150 degrees. We know that this angle over here is 20 degrees. So we could find the angle at the top right here by knowing that this angle, let's call it theta, this is equal to the 180 degrees minus the 150 plus 20 degrees. So that's 170 degrees. So 180 degrees minus 170 is 10 degrees. So now we know an angle and we know a side across from that angle. So let's use a law of cosines, not law of cosines, law of sines. And so we have, and what are we trying to find? Let's find this height. Let's see, actually, what would be the best? If we find this height right here, this length right in here, finding this one right in here, let's call that x. So I know that x all over the angle across from it, sine of 20 degrees, is equal to 40 all over sine of sorry. Yeah. 40 over sine of 10 degrees. So I have x is equal to 40 sine of 20 degrees all over sine of 10 degrees. So looking at this, plugging it in, we get that that is approximately, and I'm not going to round too much, well, let's go to the nearest tenth. So that's approximately 78.8 feet. So if we know this angle in here, not angle, side. I'm not sure that we can assume that this is a right triangle in here. If we could assume that's a right triangle, then we would know what we're trying to find, which is y. It does say that it's a flat path. So maybe we can just say that this is a right triangle. And this, we're trying to find y. Now we know what the hypotenuse is, which is 78.8 feet. So I'm trying to find opposite. I have hypotenuse, so I could use sine of 30 degrees, which I hope you know, is equal to opposite, which is the side length of the tree we're trying to find, y, all over hypotenuse, which was the 78.8 feet. Sine of 30 degrees is 1/2, is equal to y 78.8. So multiplying both sides by 78.8, I get 78.8 divided by 2 is equal to the height. So it's getting that it's approximately 39 39.4 feet. Let me just check that really quick and see if we got that right. Yay, we got it right. So the height of that tree is 39.4 feet high. Okay, so that was the lecture on law of sines. I thought I was going to get to law of cosines this week and Heron's formula to find the area of non-right triangles, but we didn't get that far. So the only thing that you have this weekend to do, besides doing your lecture notes, is doing the section on law of sines, which in our book is 9.2. And then you have the end of the chapter test on MyLab, opening Friday morning at 10 a.m. and you have until Sunday evening to 11:59 p.m. to take that exam. You'll have 3 attempts to take it. You'll have to take it in one sitting each time. And I believe it's 75 minutes that you have to take the exam. So I would try it early on. I wouldn't wait till the last minute to take that. Try it, see how you go, how you do, and if you need to study up before you get back on and retake it, then you know what you need to study on. So that is what we have for this week, week 11.